Greetings, intrepid explorers of knowledge, and welcome back to PaperLedge. I'm Ernis, your host, ready to guide you through the fascinating, often perplexing world of academic research. Today, we're not just skimming the surface, we're diving deep, Jacques Cousteau style, into a paper that tackles a surprisingly common problem in AI reasoning. Have you ever noticed how even the smartest AI sometimes jumps to conclusions, like a student who answers the first question on a test and then declares it done? We'll be unraveling a new paper titled SmartSwitch: Advancing LLM Reasoning by Overcoming Underthinking via Promoting Deeper Thought Exploration. It's a mouthful, I know, but trust me, the insights are worth it. In this study, our researchers at the Hong Kong University of Science and Technology and the Chinese University of Hong Kong shed light on a critical flaw in how large language models, or LLMs, tackle complex reasoning. Now, imagine LLMs are like cosmic detectives, sifting through galaxies of information to solve mysteries. The key idea is that these AI detectives, despite being incredibly powerful, often exhibit what the researchers call underthinking. It's like they're given a magnifying glass but only glance at each clue before moving on. The researchers found that LLMs frequently switch between different lines of thought without fully exploring the potential of any single idea. It's almost like they're afraid of commitment, flitting from one shiny object to the next. So, how do we fix this? Well, the paper introduces SmartSwitch, a simple yet effective framework designed to encourage these LLMs to stick with a promising line of reasoning a little longer. Think of it as a gentle nudge, or maybe a stern talking to, reminding them to look closer. We can use the loci technique to construct a mental memory palace to understand this. Imagine a grand, Victorian-era mansion. The first room is the perception module. This is where SmartSwitch eavesdrops on the LLM's thought process. It's constantly listening for linguistic cues, like the phrase, alternatively, which signal that the LLM is about to jump ship. Next, we enter the reward room, where SmartSwitch uses a process reward model, or PRM, to evaluate the potential of the thought that's about to be abandoned. Think of the PRM as a wise old mentor, whispering in the LLM's ear, hey, that idea might actually be worth pursuing. If the PRM gives the thumbs up, we move to the intervention chamber. This is where SmartSwitch steps in and interrupts the LLM's thought process, like a director yelling, cut, on a movie set. It then injects a deepening prompt, a carefully crafted phrase that encourages the LLM to explore the promising idea further. It's like saying, wait, this seems like a promising idea. Let's dive deeper into this reasoning path and not give up easily. Then the LLM goes back to the perception module to see if it found a valuable answer, and this cycle repeats. It's like a cosmic dance of thought. Now, you might be wondering, does this actually work? The researchers put SmartSwitch to the test on a series of challenging mathematical reasoning benchmarks. These weren't your run-of-the-mill textbook problems. These were competition-level questions designed to stump even the smartest humans. And the results were impressive. SmartSwitch consistently improved the performance of various LLMs, boosting their accuracy and efficiency. In some cases, it even helped smaller LLMs outperform their larger, more powerful counterparts. The researchers evaluated SmartSwitch on 5 well-known mathematics benchmarks. These included 4 competition-level datasets, A24, A25, 23, and Math 500, and 1 standard-level benchmark, Gaokao 2023N. Their findings showed that SmartSwitch consistently outperformed vanilla inference strategies across different LLMs, demonstrating compatibility, generalization, and robustness. What's more, SmartSwitch didn't just improve accuracy, it also made the LLMs more efficient. By encouraging deeper exploration of promising ideas, it reduced the overall number of tokens used and the time required to reach a solution. Less rambling, more solving, Morty. But here's the really cool part. SmartSwitch is designed to be plug and play. It can be easily integrated into any LLM, without requiring extensive fine-tuning. It's like adding a turbocharger to your existing AI engine, giving it a boost without requiring a complete overhaul. The researchers even found that SmartSwitch could identify and recover reasoning pathways that could have been correct and maintained 100% accuracy on solved problems. Now, of course, the paper isn't without its limitations. SmartSwitch relies on an external process reward model to evaluate the potential of different thoughts, and the quality of this model can significantly impact its performance. As they say, garbage in, garbage out. Also, the thought switch detection mechanism is currently based on linguistic cues, which may not capture all instances of premature abandonment. But overall, the SmartSwitch framework represents a significant step forward in our quest to build more robust and reliable AI reasoning systems. It's a clever and practical solution to a common problem, and it offers a glimpse into the future of AI, where machines are not just smart, but also persistent and thoughtful. So, there you have it, folks. Another mind-bending journey into the world of academic research, brought to life here on PaperLedge. I hope this episode has sparked your curiosity and inspired you to explore the wonders of AI and the human mind. Now, go forth and question everything. And until next time, keep reaching for the stars.